C hash map implementation. So this has a good amount of stars. Stars. So how does it work? Open addressing, we don't care about that. I don't really understand this stuff that much. But I just want to see the allocation part. Create a new hash map where each item is a struct user. The first one has more stars. Let's just use this one. Hashmap.c. What do C... what are they called again? Doc blocks look like? You know, Copilot is pretty good at adding comments. So now we need HTTP request, parse result, and parse HTTP headers. Do we have a headers part? We don't. So we're gonna add that right now. Let's go to the README. How do we create a new... Wait, what? Why are they using user compare? Oh, you need to pass a compare function. Interesting. So it doesn't just like let you pass a key value, like a separate arguments. You have to pass one thing and then specify a function, a comparison function, which is fine, I guess, but it's not. It's something that I'm not used to. What's it called again? Struct hash map. And headers. Should I be storing the headers, or I should be storing the headers in a hash map, correct? When parsing the request and preparing the response. Come on, come on. Why is this so slow? Let's see. Interesting question. Classic data structure trade-off. Oh, maybe not. Headers can appear multiple times. Ooh, I didn't know that. Hash maps typically store one value per key. Sure. Case insensitive keys. We can just normalize. Just basically convert all of the keys into lowercase or uppercase. So you can solve this problem. All are equivalent per... You need case insensitive. Hashing comparison, yeah. Small data set. Linear search through an array is fast for small n. Hash map overhead might be slower. Yeah, that's kind of true. Order sometimes matters. While HTTP doesn't guarantee order preservation, some applications depend on it. Hash maps typically don't preserve insertion order. And then we have iteration requirement. I see. Maybe we don't need a hash map. Sure. Should I add a vector implementation then? Or can I just get away with standard C arrays? So I guess with C arrays we can over allocate, just like basically create an array of 50 pointers for like 50 headers. 50 would be the maximum number of headers that we would support. And as we parse them, we basically add them to the array and increment a counter for the length. That could work. And I think it's the simplest. And it doesn't like take too much memory. Another solution would be to use a vector, which is a dynamically sized array. So it grows and shrinks as you add or remove items from it. So let's see what it says here. You can absolutely use static arrays. Are perfectly reasonable. Bounded problem domain. More than 100, probably an attack. Yeah. Will servers impose limits? 2000 in Node.js. Interesting. We want a hard limit. Static arrays enforce this naturally. Simplicity with vectors. Yeah, let's do that. We'll make the implementation simpler, which I like. Let's keep the hash map implementation for now. We might need it later. And let's create a struct for the headers. So it's going to have a size t count or length. Keys. Should we store the keys separately? Yeah, it's going to be a double pointer. Can HTTP header keys or values contain null characters? I think this makes it simpler. We would have to enforce it though. So here's what I'm thinking. We don't interact with this struct like directly. What we do is, well, let's see. Okay. Control characters are not valid. Let's maybe add a to-do for this. When parsing the path name. Where's my path name? Should be called path name. To do validate control. make sure path name doesn't contain control characters. So what will the function look like? So parse HTTP headers. We add a header. It does not take in a request. It takes HTTP headers. Arena, is it gonna do the allocation itself? I don't think so. We're gonna pass a pointer to the key, which would be already allocated, and a constant to the character, add to the value. We are not going to do any allocation. So this is gonna look like this. Keys. Hey, why are we casting it? Oh, it's because it's const. We need to impose a limit. And why am I writing C code in a header file? We need to go here. And let's do this. Define max header means sure. And let's also define max headers. 100 is a good amount. If the length is bigger than or equal to max headers, we return. But it's not going to return void. What should it return? I think a boolean makes sense here. So in this case, it's false, otherwise returns true. And don't forget to increment. I don't like the double plus sign. I think this one looks better. And let's add another function, which is find HTTP header, which takes in a key and returns it in a value argument. And how do we communicate that it doesn't exist? I want to look at the code for the hash map. What is hash map So we have count, clear, free, scan, and iter. Where's set? Oh, set and get. It returns a void pointer. To what exactly? Oh, return the previous. That's pretty good. Get an existing item. So it returns it, it doesn't put it in a pointer argument. You just give it the item because so that it can, you know, compare the key. But it returns the item that it finds as a pointer. Should I do that? I don't know. I kind of like this more. There's the length. I's plus equals 1. We stir compare header keys with the key that we're given. But we need to make sure that we don't... Oh. That we don't overread. I think if both strings have a null terminator, that should not be a problem. Does stir compare stop when it finds a null term in either string? Yeah, cool. Otherwise, this is going to be null. Oh yeah, this is complaining because it's size t. This looks pretty good. Very cool things. We can test this in a bit. We also need to add the header parsing part into our like this function. So what do we need to do there? We need to read basically until we find a colon. So can, what's it called? Header keys or values contain a colon. Since it's the separator. Let's see. It depends on which part. So keys cannot. And so we need the ability to delete a header. And it will return a boolean, just indicating whether the header was found and deleted, or it wasn't found, I guess. That could be helpful. And it only takes in a key. What else? We also need to make an iterator. Yeah, I mean, clear could be useful as well. Clear them. And yeah, we need the iterator function. No. How would that work? Let's look at the hash map thing. Iterates over all the items. Iterates one key at a time, yielding a reference to an entry at each iteration. Useful to write simple loops and avoid writing dedicated callbacks. But how do you reset it? Oh, I see. You basically give it the index, and I think when it reaches the end, it just returns false, right? On the hash map being iterated, the buckets are rearranged. And the iterator must be reset to 0. Yeah, that's a bug that I've ran into in the past. You know, like trying to modify an array while also iterating over it. Like removing or adding items to it. You should not try to do that. So I think I like this one. HTTP headers. Yeah, I don't like the naming of these functions. So let's do the opposite. We're gonna prefix all of them with HTTP headers. So delete, and then there's clear. And find. And there's iterator. Which will not take a function pointer, but instead it will take an index. Yeah, I don't like this being a double pointer. We're not going to be copying values, I don't think. We already have the data allocated, so we'll just return it. The caller is responsible for managing the memory. And it returns a boolean. Let's try to write all of these. So parse is not parse. I think this one is add. Yeah. We don't need to cast here. And delete, which returns a boolean. It's a single pointer. Wait, oh, I see why it has to be a double pointer. No, that makes sense. If it is found, we return true. Otherwise, return false. Why is it conflicting? Delete. Oh. Now let's add an out value. Oh, let's call it deleted value. It is still complaining. Why? Oh, it's because of this. Sure, let's make it a const. So we have add and delete. What's next? Void clear. Which basically just sets the length to 0. Which I think is fine. Next. And there's find. So here we did not really delete, did we? We just looked for the value and returned it. Yeah, this delete thing is going to be tricky a bit. So let's do this. We have find. Let's also make it return a boolean, so we can check either the boolean or the out value, whichever one you want. We set the out value if we find the key. Yeah, we set the out value and we return, or that we return. And what we can do here, I think, if I'm not mistaken, we can do something like this. We can find key and deleted value. Let's do bool found. If found, let's just check for. Yeah, but we can't guarantee that the caller will set the deleted value to null. So let's just check the return value to make sure that it was actually found. So basically found. Here we're gonna assume that the deleted value is not null. You know, this function guarantees that, so nope, I did not want to autocomplete. I mean, we could shift them like this, but that's not cool. What I like to do is do a mem copy. So basically, this will look like this. Let's open a Xcode draw just to explain this. Quickly. And let's have lines, you know, just to separate the memory cells. Well, let's just keep it the same height, it doesn't matter. Oh, for some reason it's not. Oh, now it works. It doesn't work when I press shift, and it should constrict it so that it only moves horizontally, but it doesn't do that for some reason. So I think this is enough. So let's see here. Let's say we have, why is my keyboard not working? Oh, I see why it wasn't working, I think. But anyways, so we have key, let's call it 1. We don't really care about the values. And I keep pressing Windows for some reason. 2, 3, and 4. And yeah, so the headers is basically an array of pointers, right? It's an array of pointers for the keys and the values. So this one, I think, we can assume, or we can, I'm just going to explain this with an example that only reallocates or, you know, fixes the keys. But yeah, you can apply the same thing to the values. It works pretty much the same way. So what happens is, let's say that we want to, for some reason it does not want to give me the text tool, delete key 2. And what this does, it will basically remove key 2. And we don't want to end up with like an empty space, because if we try to iterate, how do we keep track of all the empty spaces like that's between or in the middle? So we need to move everything on the right backwards by 1. I mean, we could go over, you know, the cells 1 by 1, or the character, what is it called, the array elements 1 by 1, and just copy the next one backwards. But mem copy will basically just copy a chunk of memory, and we can give it the start of the chunk, which is the next element after the one that just got deleted. So it will be here. And the length, which is 2. Right? These two. And what mem copy will basically do is that it will take these. And yeah, we have to give it a destination as well. The destination is basically here. And we can type these. Destination, source, and length. And what it will basically do is it will take the source, you know, times, so basically starting from the source, the element size times the length, and it will move it to destination. So we end up with this. Actually, like in reality, we end up with this. So this will be on top of this, so it will overwrite it. So it will be key 1, key 3, key 4. And key 4 again, it will not delete or clear the memory at the source. So after we do the deletion, we can just set the max length. Header's length is going to be 3. Or it's going to be the original length minus 1. So we started with 4. It's going to end up with 3. So, and that makes sure that we don't access or accidentally access this deleted, or not deleted, I guess, the moved element, which is a duplicate of this basically. I hope that this works and I didn't just spend 5 minutes to explain something that will have a bug when implemented, because yeah, that sometimes happens to me. I'm confident that something will work, then I write code, turns out there was something I didn't think of, and there's some weird edge case that requires a different implementation. So let's actually do this. Found. Ooh. Yeah, we need the index though. And let's change this to size t. So what I will do is it will return -1. Oh, that doesn't work though. Oh man, that's not good. Let's just do an int. So here we'll basically just return I. Here we'll return -1. So if index is bigger than -1, destination is going to be, what is destination is going to be? It's basically going to be headers keys I. Index, sorry. The source is going to be headers keys index +1. And the size is going to be headers length minus index -1. Is it going to be -1? So let's look at examples here. Let's say we have an, this autocomplete is distracting me. Let's say we have an array of empty. Let's start with an empty array. That's a good example. What happens then? We call delete. Find will not find anything, and it will just, the index is going to be -1, and we will just returns -1, or false, I guess. Let's say we have one key in there called T1 or K1. We go here, we find it, index is going to be 0, which is bigger than -1. But we don't have to copy anything in this case, because there's only one element. Everything after it is just garbage data that we don't have to care about. So we need to do a check here. Length after items to move. Yeah, that's exactly it. Which is going to be length minus the index -1, which is, in our case, index is 0, length used to be 1. So 1 minus 0 is 1, -1 is 0. And we do a check here, items to move is bigger than 0. Then what we do is, this is going to be the same. What is it called? The source. The first argument is destination. Source is going to be index +1. And we don't have to worry about accessing, out of bounds array elements here, because we did a check here that items to move is bigger than 0. Yeah, but does that guarantee? I think so. And we can just do items to move. Items to move times, let's do the reverse. So it's going to be a size of character pointer times items to move. This part is needed because we don't know the length, or like the mem copy needs to be, well, let's do mem move. What's the difference of overlapping strings? What's the difference between mem copy and mem move? Yeah, this part, as I was saying, like size of char pointer, is basically the size of one cell. Like how many bytes is it times the number of cells that we want to move. Like let's say you're trying to, you took a slice of cake from a big cake and you want to move like all the pieces after it, or all the slices after it, to fill the space that your slice was in. You have to also, like, it's basically going to be the size of each slice, considering that they're all the same size, times the number of slices that you want to move. Because if you don't pass this to mem move or mem copy, it will basically, you might end up moving half a slice, where were we? Overlapping memory regions. Assumes source and destination do not overlap. If they overlap, behavior is undefined with mem copy, typically faster because it can use simple block copy instructions, save for overlapping. Okay, I don't think we have overlapping here, so we don't care about it. So we can just use mem copy, which is supposed to be faster, I believe. And it returns a pointer for some reason. What does that do? To dest, okay, which we already have. So I think this should work. We will have to revisit just to make sure. Oh, we forgot to do something here. Yeah. We need to copy the values as well. And one last thing is length -1. Wait, actually, this has to be here. And we return true. Or we could just return the index, because why not, since we have it. Why don't we also return the index from add? I mean, communicating extra, information to the caller. That wouldn't hurt, right? Return -1. Otherwise, what? My fingers are freezing and I can't type correctly. So delete now should return the index as well. I think in either case, so we can just remove this return. So what do we have now? I think find works now. Oh, yeah. Deleted value. That should also work. We need to test this stuff. So iterator. So if index is bigger than or equal to, but why is index a pointer? That's what I'm confused about. Because it will basically auto increment it. But do we want to do that? Let me sure. We increment index, we return true. If index is bigger than or equal to headers.length, that's false. And that should do it, I think. I mean, hopefully we haven't forgotten anything. I mean, let's just have this also return. Oh, let's be consistent. You know, and we just return the number of deleted headers. Even though I don't think that's ever going to be useful, but let's just do it anyways. Just so that, you know, these functions look uniform. All of them return ints. We might have to add like a bit of documentation or doc blocks, if you will. So now let's go back to the real meat. The hard part. Parsing the headers. I'm gonna work on the right here because I hate looking at the left side of my screen. Where were we? We asked Claude about this last time, and I think we were asking about the null terminator, right? So the key actually could contain a colon, but not the value. So how do we want to do this? FD buffer read until. So connection reader. And I think, so what's the max length of a header? It's 8 kilobytes. I'm thinking we could just do this. We could have like global variables that we can reuse just for this function. So we don't have to, you know, allocate and clear every time. So it's basically going to be character header key. Nope. This thing is for the entire line though. Should we have separate limits for key/value? Or, I have an idea. Let's just do this. So header line, yeah. That's perfect. And this was destination, header line. The limiter is going to be this. But can we use read until? Because this will not check if we have a null terminator. Header line length, which is an int. Max bytes is going to be, I think this. No, let's read the entire thing. Okay, so I think I have an idea how to do this, on how to do this. Why is this complaining? Oh, it's supposed to be a pointer. This one too? No? Oh, sure. My bad. That would be my bad. Okay, so first we'll read the entire thing into this. And we need to check. What does this return again? 0 number of bytes read, delimiter found, or in the file. Delimiter found. Ooh. This part is confusing. Bigger than or equal to 0. What did I do here? Incomplete request. Because that's the status line. But with headers... I wonder if it's valid, like as a request to have the status line and then the body right away with like the 0 headers. And I'm worried about that, you know. In that case, we will basically find the delimiter, but the length will be 0. Can a request have no headers at all? Do I need to support that? So basically the status line and the body right away. I wonder. I mean, take your time. It's a hard question, isn't it? Let's see. Short answer depends on the version. No, must have at least one header. That's 1. Can have 0 headers. What about 2? Super strict. What about HTTP 2 and 3? Okay. I mean, I kind of want to support it anyways. Oh, this is bad though. No, never mind. This function should have a separate return value for when the limiter isn't found. I think this comment is wrong. Because if max bytes, if we exceed max bytes, then we're not gonna read the delimiter anyways. So if it is 0, not really, it's not gonna be an incomplete request, but we're just gonna headers complete. What? That's not what I wanted. We need to add the headers here. Length is going to be 0 and we'll just return. HTTP parse OK. Here too. Unknown read error. The limit exceeded. Yep, that looks good. And we need to do this in a loop. So I'll have to do that in a second, but let's just finish parsing like one header at least. Ooh, that's a problem. I just realized something. So when the headers finish, technically we have two of these, the \r, \n. So when we read the first one, that's supposed to be a header, but then we read the second one. So no, the headers are not going to be 0. But when we read the second one, that means finished parsing. Finished reading headers. Let's add a comment explaining this. Because of the two consecutive, yeah, at the end of headers. Yep. I hope I'm not wrong here. Search token, right? Mem character. No, we're not going to use that one. We're going to use stir.tok, I think it was. Give me the docs for, or I could just look at the man page myself. Point to a modifiable null terminated string. Replaces each delimiter it encounters with a 0 and returns a pointer to the next token. Can you give an example? There we go. Token returns a pointer to the next token. Okay, so separator. You will take in header line, right? That's a problem. What if header line does not? You know, oh, let's just use mem character. I kind of like that one better. Character is going to be this, and length is going to be yeah, max stuff. No, actually, it should be header line length. And this is a character, not a string. And what does it return again? Matching byte. Just 1 second. Okay. Yeah, but does it modify the first argument? I don't think it does, right? Okay, so let's say we found a separator. It was not found, malformed. Yeah. Key length, yeah, is basically separator minus header line. And value is basically just... So now what? I think we need to allocate. Not yet. Key is gonna be, yeah. A value is gonna be this. What we're basically going to do is then copy. Destination is key, header line, and yeah, and we add a null terminator. Skip leading white space in value. Do we need to do that? I think so. Yeah, so basically value start is separator plus 1 because we need to skip the separator if value length is bigger than 1 and value start is an empty white space character or a tab for some reason. I mean, let's keep that. We increment the start, we decrease the length. Then let's just copy. Come on, autocomplete. Value start, value length, that makes sense, all of this. And we basically have to do this in a loop. And don't forget, yeah, there we go. We have the key and the value. Check. We'll do this in a second. Just do while true. So when do we stop reading headers? Here. So let's do this. Let's just basically make and run the server. We parsed the status line. Let's go to this function. Okay. Parse headers. We do this now. Not status, headers parse result. And here it is status line parse result. We run, we get a seg fault. That's not good. Why did we get a seg fault? Or I guess where did we get a seg fault? Let's start here. We're getting header line. It should be like this. And it's, why is it empty? What if I print? Let's not do printf. Let's use debug. Let's do connection reader buffer, I think. Let's see what happens then. What about the position? It's 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then 16, 17 with the \r \n. And then we are here at the headers. But I should print here. This is where we parse it. I was printing above for some reason. So now, when I do this, header line length, not length, just header line. Let's actually print the length as well. Let's print this on a new line. These should be reversed. Let's remove the tab. So I did read it. But then what? It only read 1, so that means our issue is probably somewhere here. I could just launch GDB or what is it called? The other one? I think LDB. I think, yeah. But let's try to debug it with print first, or try to figure out where the problem is. So I think all of this is fine. Let's see if we found the separator. Nope. It is at position 4. So that's 0, 1, 2, 3, and 4. That's correct. Then we have key length and value length. Let's print both of these. Key length is 4. Value length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think the 16 is the starting white space, like this white space, which we skip, I think. Then we do a mem copy. Key length. So from header line, that's the beginning. We copy into key, and then what? We copy key length, basically. Skip leading white space. That looks good. Then we do another mem copy. Let's do a print here, why not? Header key is host, but before that it should be garbage. It doesn't print anything. Looks good. Let's look at the value. The value looks good as well. So it's probably this function. What's going on here? We're trying to write into them, but we didn't really allocate anything, did we? So they're part of the request, I think. They're right here. Oh, I think that's the... Where's create request? So basically here the issue is that the out request is currently null when we should be passing a pointer to a request. And I think what we can do here is I mean, one option would be to add a function that a function called like create HTTP request, which, you know, sets up the, you know, creates a struct, basically, uses malloc to create a struct and allocates space for the keys and values in the HTTP headers struct, and that's it. And then we can use parse HTTP request to populate the struct, which is fine, I think. One thing I don't like is that what if you create a request and then forget to pass it to parse? Now you're kind of like in the state of like you have a request struct, but it's not populated, and I don't want to have that. So I wonder, maybe it's better to return the request that gets created. I'm not sure. This might be a good question to ask Claude here. You can see, is it better to have a function that initializes, I guess, creates a struct, allocates memory for it, and returns it, which then another function can take and populate, or just to have the second function do everything, including creating the struct. I wanted to go on a new line to give an example, but it just sent the message. I mean, hopefully Claude understands what I mean here. If it doesn't, I'll just send another message. Thing create, thing init. Yeah, easy to forget to initialize. 2 error conditions to handle separately. Combined. This function parse HTTP request, which takes in I mean, maybe I'm overthinking this, but let's just see. Should the caller decide where output request lives? Or should the parser always allocate it on the heap? We're gonna have a function, HTTP request, which creates it. Then we can go here. Size of character pointer, this looks good. And now we can do this and just pass it in a pointer to it, actually. And now I think the parsing should work. We still get a seg fault for some unknown reason. Where's my header parsing? So we have one debug. Let's remove the new line. Add a few lines after. So it's parsing the first one, but then what happens? Let's do debug print here. Added header. It's still not adding it. Why does that happen? We have request. Let's go back to main and debug print. Yeah, let's just do headers dot length. This is size T, I think it's ZU. It's not even printing anything, is it? Oh, interesting. Oh, what am I doing, man? Oh, this is my test code. This is why it's not working. Because I need to do it here. That was kind of stupid. Added header, but we don't return anything here because we want the loop to continue. Okay, let's actually validate this. I'm thinking that maybe we should add some tests. You know, like this stuff is complicated and it's pretty easy to break if we decide to add any changes later on. And I don't want to like go over and just test things manually. So this is useful, but let's print yeah, method path version. Let's just panic here without anything. And then I want to exactly print all the headers basically. So we have post, path name and version. And we have all the headers, I think. Content length. Yeah, this looks pretty good, if you ask me. Let's try to modify our HTTP request and see what happens. What if we have no headers? Then they're just 0. And what if we only have one of them? Or like one \r\n. It still parses when it shouldn't, which I'm not a big fan of. So what is it doing here? So we enter this loop. After we were done parsing the status line, we enter the loop. We read until the next \r\n. But we don't have one. Or do we? Do we have one here? I don't think we do. Oh, we do. Why do we have one at the end? How do I want to remove it. Where did that come from? Okay, so I basically edited my vim config or neo-vim config to treat .bin and which one? So .bin, .date, .dat, and .raw files as binary, so it doesn't add like extra, what's it called, end of file and like weird stuff when I save them. Just in case I need to edit binary files. And I'm also thinking of adding a few commands for where's my binary section? For editing, basically a hex editor that uses XXD. Converts the file into the XXD output, which then I can edit, and then I can basically save and not save, I guess, use the other shortcut to revert back. Can you give me two normal mode shortcuts for binary editing with XXD? And that converts into XXD format. Other one converts back. Yeah, basically these. Leader X. Yeah, I think that's good. So XH is hex and then back to binary. And let's test them. And then we do this. Okay, that did not work. Oh, it's because it was already in hex, so this should work now. And if I do this again, as you can see, it works. However, let's do an ASCII table. I think we may have messed up the response. What's 31? That's 31 in hex. It's this one. It's a character 1, so it's this. And then there's 0A, which is line feed. But we don't have a carriage return, which is a problem. So it's supposed to be like this, I think, right? Yeah, the carriage return first. So what we need to do is we need to have 0D and then 0A here. And then we do this. And hopefully XXD can understand what we just did. So this is actually an invalid HTTP request because we should have two \r\n. Can you show me a valid simple HTTP request? Make sure to show the separators. We should have two of these after the headers. And if we don't have any headers, then basically we need to have one right here, I think, and then two after it. Or is it just one? I'm not sure. Let's take a look. So we have 1, 2, and 3. Can you show me one with only the status line and a request body with no headers at all? I just want to make sure, like, does it have 2 or 3? I think you mean request line. Yeah, sure. So it's 1, then 2. Missing host header, missing content length, and missing content type. I mean, we could do that. Where's parse request? Parse headers, we're done with that. I guess to do HTTP 1.1 requires host, content length, and content type. While not strictly required. Host, content length, and maybe it's content length, maybe content type. Validate headers. But we had an issue last time. So if we go to main, we were trying to parse this thing. What was the command again? XB. If I do XH again. So 0D, 0A. This looks fine. So this is supposed to be an invalid HTTP request. So we need to reject this somehow. Let's see, I think this runs right now, which is not good. Yeah, it does. So it parses the request line, but then it panics. And it doesn't touch the body. So I think what we need to do is, let's go back. Nope. Nope. So the status line parser parses this like first line, and it also consumes the \r and then \n here. Oh, where's the 0D actually? Didn't I add it? I did. I'm not 100% sure how does editing work in x60, or if I want to add extra bytes either in the middle or at the end. Yeah, I know that. Adding bytes in the middle. You may ignore the ASCII section. Sure. Add bytes at the end. Yeah, I mean, this is definitely annoying. So 0D, 0A. I mean, let's do this. I mean, this time this works. Let's go back here. Run. It works. And we were saying that, so parse status line or request line, we should rename it. Parses the first line and it consumes the \r \n. And then there's the headers section. So we go here, while true, we have the header line. And we look for the next \r \n. So this was the first one, which we consumed already. Then we look for the second one. But what if it didn't find it? So I think what's happening is that it's not finding it, it's reaching end of file. Where's EOF? Bytes remaining 0. What is bytes remaining? Well, let's debug print here. So length is -2. Why is that? Max bytes limit exceeded. Well, this is incorrect. So end of file reached. I think we need to add a separate error code for this. Return -3. And now if we go here and we do this, here's -3. We do incomplete request. So now parse HTTP headers. If parse result is not okay, let's go back to main. But here it's not failing though. Why is it not failing? One, two, three, four, five, six. It's incomplete request. And it's being returned. So if we go to main, let's debug print here. Ooh, why is it 0? This is confusing. So it's returning okay, but it's not. And here we're checking if headers parse result, which in our case is 6. If it does not equal 0, oh, we're turning the status line. Completely missed that part. Status code 6. So now it makes sense. Let's see, it fails, which is nice. Now what if we do... What if we actually fix this and add another one of these? So now we have 0D, 0A, 0A, 0A. No. So we have 0D, 0A, and then 0D, 0A. No, it's more like it. 0D, 0A, 0D, 0A. That looks good. And now it parses. We have no headers, which is fine. And I think one thing we haven't handled is we should add asserts. I think they're good. Header, line length. Just in case we forget to handle like a specific error. And handled. I guess it could be 0, I don't care. Parse request line. This one also needs this. And if we so if it's 0, when is it 0? If end of file is reached, or ooh, we need to fix this. -3 for end of file. Wait, I'm confused. Do we actually need like a separate error code for end of file? Why can't we just return 0? I think that's fine. Just return 0. But what happens then? I mean, here we already have a check for this, which, you know, says incomplete request. What about parse headers? So how's this gonna work? This is wrong. It should be like this. So we parse the status line. If there's no headers, then we're gonna get a \r\n. So this one, which we're gonna consume. So the header line length is gonna be 0. Yeah, we do. We need to tell the difference. Let's see how read does it. Man to read. Where's EF? Read from a file descriptor. So 0 indicates end of file. But this is different. This is reading until we find a terminator or a delimiter. So in this case, we can just break here. If the length is 0, then that means, so end of file reached. We reached the end like without finding anything. And here, bytes read will be 0 if we actually find the delimiter, but we found it right away without like any bytes in between. So what we read will basically be 0. In that case, it would be a correct request, which we don't want to reject or error out. But the other case is if we reach end of file without finding the delimiter, then it's a problem. And I don't actually like these -1, -2, and -3 return types that much. I want to create an enum. For reader. Read result. I don't like how my function returns errors. It kind of mixes them with the length as when kind of mixed together with the length of the red data. Should I maybe return the status? Should I maybe have the status as the return value and add an extra argument for the number of bytes read? Or what's the best practice for something like this? Let's see. I think the best solution might be to just return this and have an extra argument. But let's see what Claude says here. I know I shouldn't be like spending too much time on this stuff, but you know, I want to learn the best way to write C code. Great question. Overloaded return value. Compact, common in Unix APIs. Mixing concerns. Magic numbers. Pattern 2. Oh, which one is that? Yeah, okay, I'll just do that. It's an int pointer, bytes read. It will start as 0, but we need to do this, this, and this. But we don't return bytes read here. We return read OK. What is -2 again? Max bytes limit exceeded. Read EF for delimiter. And then we have this. Yeah, this looks good. We'll fix the other function when we need to. So now we can yeah, these are kind of descriptive already. And this shouldn't be here. It should be here. So read result. Let's just copy it from here. Do this. And we're done. This looks good. Now let's go to all the references and try to fix them. That's a long name for a variable, but it will do. So 0, what does 0 mean again? So let's check for errors first. -1, what was -1? Normal read error. -2 again. 1 sec. Oh, it's not here. It's in buffer.c. Is max bytes limit exceeded? What did we have as the last one? Incomplete request is and the file reached before the limiter or 0. So either the length is 0 or we have an error. Now we don't have to do this anymore. And let's do the same thing here. Read result. What is this called again? Header line until result. And this is a pointer. If header line length is 0, so we always need to check errors first, actually. We need to make that distinction clear because the length variable won't be set if we don't. So raw status line length is 0. Handle errors first and then check length. It's important to go over the errors. Actually, this is not good. Yeah, this is not good. What we need to do is yeah. I mean, this is good. And I just exited Vim. Wow. Wait, what did I do? Oh, that was my clipboard. Where were we? Request.c, I think? Yeah. Does not equal. Or just panic. Wait, why is it complaining? Undeclared exit failure. I think that's in standard library. It is. So does assert like say which line it failed at? I wonder. Main.c 51. But why didn't it not go here? Hello. Wait, how does assert and C work? Then it ends with abort. But it should have aborted here, but it didn't. Why did it not abort? Oh, does it only abort when it's true, not false? What? Neither works. Oh, okay. Why not asserts? Yeah, because it disappears. Okay, let's just use panic then. I mean, we're definitely learning, even though this stuff is taking a bit of time. So we're checking if not, read okay. So we check all the errors first. Oh, I kind of like this actually. Yeah, this is definitely more readable than what I had. So now we gotta remove this and this. Empty line indicates the end of headers because of the two consecutive. Oh, this is incorrect. Let's take this and just put the examples here. So here we have one, which we already consumed when we parsed the status line. The other example is we have no headers, so we parse this and then this. When we try to read the headers, we only find this, which, you know, belongs, I think, which basically marks the end of the headers section. So if we found that, then I think we need to have an extra check here. Because normally, actually, never mind. Because even if we have one header, this while loop will run once. It will read the first header, then on the second iteration, we'll basically consume this, and we're left with the body. And if we don't have any headers, then on the first iteration, it will just basically read this, and we're also left with the body. I got confused initially because I thought that, like, there was an edge case where, like, you know, sometimes it consumes this, and sometimes it doesn't, depending on whether we have any headers or not. But I think this should work.